Hey Algebra 1, Mr. Schachter here to help you graph an exponential function. So in order to graph an exponential function, you got to make a data table. You got to make an x, y data table, okay? Now in order to make it really accurate, you want to make sure that you include some negatives, 0, and some positives. So I usually do the window of -2 to +2. In order to kind of figure out what the answer to this question is, you simply have to take these values and plug them into your function, all right? So let's start with 0. If I were to take 0 and plug 0 into my function, I would have y equals 2 to the 0 power. And 2 to the 0 power is equal to 1, because anything to the 0 power is equal to 1. Okay? Now, it's no surprise that the value of y when x is 0 is equal to 1, because I could rewrite this formula 1 times 2 to the x, right? Does everyone agree that this formula is equal to this formula? So this is the value of a, and this is the value of b. So that's pretty easy. Once you know that the multiplier is this 2 is the multiplier, all you need to do is to move down the data table, you multiply by the multiplier, 2. To move down the data table, you times by 2. So the next entry would be 1 times 2 is 2, times 2 is 4. And interestingly enough, if you wanted to go backwards in a data table, you would simply divide by 2, because if you move downwards, you times by 2, so moving backwards would be division of 2. So 1 divided by 2 is 1/2. Oh, let's get that green out of there. Let's get the red back. So that's 1/2. And then if you were to divide by 2 once again, it would be 1/4. 1/4. Okay? So let's plot the points here. So we've got 0, 1, 1, 2, 2, 1, 2, 3, 4, and -1, 1/2, and -2, 1/4. So the right side of the formula is kind of going up super, super, super quick, and the left side of this formula is getting really, 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 really close to the x-axis, but never actually going to touch the x-axis. Again, this is called an asymptote. So what's happening here is the x-axis is kind of acting as an imaginary boundary line. It's like, hey, back off, function. You can't ever cross this value. All right? So that's what an exponential function looks like. So my suggestion is to always think about your exponential function in terms of initial and multiplier, and then you can really piece the graph together quite easily. Okay?